Hi, I'm Paul. We're doing Leetcode must-know interview questions. Today's challenge is square root of x. This is rated as easy. All right. Given a non-negative integer, x, return the square root of x, rounded down to the nearest integer. The returned integer should be non-negative as well. You must not use any built-in exponent function or operator. Right. Well, Java, which is what we've been doing these in, is, of course, has a built-in square root method that we're not allowed to use. So there are several other square root algorithms. I guess the one that most people learn is Newton-Raphson. The Newton-Raphson method. So, I guess that's it's probably a good thing to know. It's a simple algorithm, and assuming that you're not Isaac Newton and you can come up with the formula from scratch on the fly, then yeah, it would be good to know that going in. What else do we have here? Input is 4, what we get back is 2, or square root of 8. Square root of 8 is 2.82842. We round it down, and we get 2. Okay. So let's do this. Well, let's start with a number, let's call it n, that we can use in our calculation, and we'll initialize that to x. Okay. What else? This is going to be our answer, root. To double, the function returns an int, the method returns an int, but that's okay. We will cast it to an int. Do we need anything else here? Yes, we need a tolerance. The way Newton-Raphson works is that it converges on the root until it is within some kind of tolerance that you can specify. So as a tolerance, let's do that. That's pretty close. All right. Now we can go into a loop. Okay. So let's say we have this. And the way that this works is, the way the algorithm works is that the root will be equal to 1/2 times n plus n, plus x over n. N is just an initial guess as to what the root might be. So as an initial guess, we're just going to use x. Okay? Now, we'll check and see if the difference between what we have calculated as the root and n, our guess, is less than the tolerance. And if it is, I think I put that parentheses in the wrong place. And if it is, then we're done. Okay. If it isn't, then we're going to set n to root and try it again. Now, to give you an idea of how this works, try copying this so I remember it, and flip over to a calculator, paste it in. There isn't going to be an n there, but what we started out is we're trying to find the square root of 16, and our initial guess was 16. And that says, well, how about 8.5? Would that be within the tolerance of n? N currently is 16, so no, it's not within the tolerance. So we try it again with the new n. And if you remember, n is the first and last number in the equation. So actually we can put it here and just say, how about if we use 8.5 as a guess? 8.5. So now we're down to 5.19. I don't know. To keep it simple, let's just call that 5.2. 5.2. 5.2. Is that within the tolerance of n? It isn't, but it's getting closer. So anyway, we would keep doing this over and over, but yeah, eventually that is going to converge to the root. So go back here. Once we break out of this while loop, it means we are within the tolerance. We can return the root. So I'm going to say let's give it a try. Compile error. Return. Right. We can't do that. It's got to be rounded down to an integer. Okay. All right, so that is accepted for a couple of very simple cases. Let's go ahead and submit and see what it does with the rest of the cases. Whoa. I didn't see that coming, but maybe the tolerance is like too much. What if we ramp the tolerance down a little bit and try and submit it? Because we are rounding it to an int. Still only, oh, okay, great. Last execution. Oh, x was 0. Oh, wait a second. Whoa, all right, okay. This can be anywhere from 0. I didn't notice that. Constraints, 0. All right? Well, in that case, let's do this. If x equals 0, return, I assume we return 0. Return 0. X equals 0, return 0. And I'm going to put the tolerance back up. Okay. Go again. Okay, that's better. Okay, so that is Newton-Raphson for square roots. Don't forget to check whether or not the input can be 0 because, well, what the heck is going to happen if it's 0? This is 0, and it was 0 plus 0 over 0. Yeah, I don't know. Anyway, don't forget to check whether the input can be 0. Anyway, I hope you enjoyed that. Please feel free to like, comment, subscribe, and see you next time.